in this video we're going to talk about the absolute value function and how to graph it and how to transform it. So the absolute value function graph is always going to be a V. Your absolute value function is y equals the absolute value of x. And it's going to be a V. Everything will be positive because if you think about it, regardless of what your y is, your x is going to be positive because of what absolute value means, which is the distance from 0. So your vertex of your parent function is going to be here at 0, 0, your parent function being y equals the absolute value of x, and your axis of symmetry is going to be right here along your y-axis. So at your y-axis, your line is going to go up diagonally with a slope of 1 going either way. So this is what your absolute value function graph would look like. So now let's talk about what happens if we want to transform it. Just like when we transformed quadratic equations, you can transform your absolute value graph. Out front, the negative is going to cause a vertical reflections, which means it's going to flip it over your x-axis. This A in front of it, if it's greater than 1, you get a vertical stretch, which means it makes it more narrow, just like we did before. Or you can get a vertical compression, which makes it flatter, if you have a fraction where 0 is less than A and A is less than 1. If it's within the absolute value signs, it moves to left to right, keeping in mind that it goes the opposite of whatever you see. And then whatever's on the outside of the absolute value sign moves it up and down. Please keep in mind that HK is your vertex. Okay, so these are transformations of absolute value. They are the same as they were when we dealt with quadratic equations. Okay, so let's take a moment and identify some transformations. We've done this before, but this time we're dealing with absolute value. So we have this 3 out in front, so it's going to get narrow. It's going to become narrow with the 3 narrows it, or it's going to multiply it by a third. This in here, it's going to go 2 to the left. It's going to go down 3. Over here, this one is going to make it go 1 to the right and up 2. Here we're going to have 2. The 2 makes it narrow. Three left and 1 down. Okay, and here we have a negative, so it's going to reflect. Then it's going to 1/3, so it's going to compress or get flatter. Which in a sense means that your V is going to get wider. So when we say makes it flatter, if this is your parent function, then when you multiply it by a third, it gets wider. That's what I mean when I say it gets flatter. This is going to go 2 to the right, and it's going to go up 1. So looking at these 4 equations, these are the transformations it would take. Remembering that the 2 and the 3 and your 1/3 kind of also do the opposite of what you would expect them to do. Okay, so let's do another example. What if I asked you to do some graphs? So let's first do our parent function. Remember when you're graphing your parent function, you're going to put a vertex at 0, 0, and you want it to climb steadily the slope of 1, 1, axis of symmetry right in the middle. So now we're going to graph another one. I'm going to change colors. Okay, so the first thing it's going to do, it's going to flip over. It's going to stretch by 2. And when you do your stretch, or I shouldn't say stretch, it's going to narrow, that affects your slope. So here, it's 1, 1, but when we do this, that's where, instead of being 1, 1, that's going to make my slope change, and it's going to be 2 over 1. Okay, so in my parent function, my m equals 1 over 1. Here, it equals 2 over 1, and that's what's going to cause my function to look more narrow. Then it's going to go left 3 and up 2. So first thing I want to do is think about the fact it's reflecting, so it's going to be down here. Now I'm going to go left 3, and I labeled this by 2's, so I'm going to come here and then I'm going to move up 2. These are also by 2's. So I'm coming left 3 up 2. So my new vertex is down here. So what's my new vertex? It's at negative 3, 2. I'm going to kind of do this. And if I think about this, what's one of my intercepts? Well, if my slope is now 2, 1, if I go rise over run up 2, so from 2 I go to 4, 1, here's an intercept at 4, where am I? 4, 4? Because I was at negative 3, 2. So yeah. And when I went up 2 and over 1, so then if I wanted to hit another point, I would go up another 2, 1, 2, over 1. So all these should be points on here. So for every one, I'm going up 2 and over 1. If I had shrunk this, I would have a slope of 1, 2. So this number out front gives you your new slope. So what's an intercept here? 4, 4. All right, so let's do another example. This time, I've got my vertex, I've got an intercept. So we know we're going to start with, I'm going to change color so you can see. We're going to start with a y equals. And we can see it's reflected, so I've got to have a negative. We've obviously gone to the right, to the right 3, and we've gone up 2. So we know that it's got to be a minus 3 and a plus 2. Well, here's my question. Is my slope 1 over 1, or did it change at all? So from 3, 2 to 1, 1, I can find my slope by using my slope formula. So 2 minus negative 2, that gives me 4, over 3 minus 1, that gives me 2. So my slope is m equals 2. So out front, I get a 2. And I could have also seen that I went down 2 and over 1. So here would be my equation. Okay, so for this one, this time, it's not reflected, so I don't have a negative. But I can see that I went 1 to the left and up 3. So I know I've got x plus 1 plus 3. So again, I have to figure out my slope so I can decide, did it narrow or compress? So this time my slope, 3 minus 7, negative 1 minus negative 3, negative 4, over 2. My slope ends up being negative, but that doesn't really affect us. Positives and negative wise. 2. So again, my slope, we get a 2, so we can see that, again, it has a narrowing factor when we grow of 2. So this would be your equation for this one. And that's how you work with an absolute value function.